Okay, guys, we're going to go over chapter 22, the section on the interactions of light waves, which was pages 644 to 651. A lot of terminology, and some of this is going to sound familiar because it has been talked about when we've been talking about waves. So we'll go over all of it. Highlight things, keep track of things. If you have questions, we'll go over them when we get together. So first they talked about a reflection. We use these terms kind of in our everyday lives, but we know what a reflection is. We might not be able to give it that scientific sort of definition, but it's the bouncing back of a ray of light. It could also be the bouncing back of sound or heat, and that's because the ray hits a surface that it can't go through. So it does happen to us in a lot of different ways. So light reflects off surfaces like a ball bounces off the ground. So imagine it that way, straight down versus at an angle. So this was a good picture. We call this the law of reflection. So the flashlight is here, and it's going to send a beam of light toward the mirror that's kind of across the bottom here. And this is what we call the incident beam. So it's the start, so to speak, okay? And then it hits that mirror, right? And then bounces this way and heads up this way. So we call this beam of light reflected off the mirror the reflected beam. So we have the incident beam and then the reflected beam. Couple things that we need to take note of is there's a perpendicular line here. We call that the normal. And then there's an angle between the incident beam and the norm. We call that the angle of incidence. And then there's another angle right here between the norm and the reflected beam, which we call the angle of reflection. So these are just some terms that we would kind of be spending a little bit more time with if we were in class, but that you'll be familiar with as you move into high school and even some geometry with angles. So we have what we call regular reflection, and then we have what we call diffuse reflection. So you can see the difference here. On the left, this is regular reflection. When the light beams are reflected at the same angle, you have regular reflection. So when your eye detects the reflected beams, you can see a reflection on the surface. And then we have what's called diffuse. If we diffuse, it goes kind of all over, and you can see that when it hits here, it's reflected at all these different angles. And you're not going to be able to see a reflection because not all of that light is going to go towards your eyes. So it's not going to be a reflection to you, to your eyes. So those are just a couple examples. So we can see a light source even in the dark because light passes directly into our eyes. So sometimes it takes a second to adjust or a minute, but we can definitely see a light source even in the dark. So when something produces visible light, we call it luminous. Now, be careful. A lot of people would say the moon is luminous. You can see, obviously, light in the moon, but it is not itself lighting up. So it is technically not luminous. That's a big, big, important misconception. So if it produces visible light, we call it luminous. The sun, for example. Now, if something is illuminated, right, it is not a light source, but it is, you can see light through it. So the moon is a great example of a visible object that's not a light source, but it's illuminated. So the moon would fit into that category. Then we have what's called absorption. So in optics, excuse me, it's the transfer of light energy to particles of matter. So absorption happens a lot, right? And then we have what's called scattering. So when light interacts with matter, it causes it to change its energy, maybe its direction of where it's moving, or actually it can have to do with both. So you've experienced that too. Light scatters a lot. For example, it's what makes the sky blue. When we look at the sky, we see the background of blue because it's scattered more than any other color. So that's a really good example of scattering. And then we have what's called refraction. So when a wave bends as it passes between those two substances, we mentioned this the other day, and the speed of the wave is going to change. So that can happen like from the example I gave the other day was, when it moves from air to water, right? That's a huge speed difference of the wave, so it's going to be manipulated. Here they're showing you light passing into a material where it's going to bend away from the boundary between those two materials. So it's glass, right? So it's going to travel more slowly through glass than it was when it was traveling through the air. So the light refracts as it passes at that angle from the air to the glass, and the light is also reflected inside the prism. So this is just a good example that you guys are familiar with in prisms. So, interestingly enough, your brain interprets light as traveling in a straight line, even if it's not. And I think that that is something that's pretty amazing. Things will look very manipulated. So, because of the refraction here, this is a great example. The cat looks and thinks that that fish is a lot closer than it really is because of the differences in the way that the refraction is causing there. So, it thinks it's really close up, right? Now, if the fish is looking back at the cat, same thing, right? It looks farther away to the fish because it's heading out into air, and the cat's actually closer. So that's pretty cool that your brain does that. So waves that have short wavelengths are going to bend more in visible light. So think about the electromagnetic spectrum that we've been talking about and the Roy G. Biv, and that's going to be very, very interesting when you think of the rainbow. So white light can be separated into different colors by refraction. So when we look, I have a thing in my classroom that I would be using right now that we could spin, but here's a great example. A prism is a piece of glass, right? It separates white light into the colors of the rainbow or the colors of visible light by refraction. So it's going to pass through right here, and it's going to be refracted twice. And it's going to happen when it enters and when it exits. So for example, the violet light, it's the shortest wavelength, and then as you move through, red is the longest. So that's what creates that that difference and that colors of the rainbow there. So that's pretty cool. Diffraction is when the direction of the wave changes. So it finds an obstacle or an edge, an opening that it can travel through. So light waves can't diffract very much around a large obstacle. So you know, obviously that's why we can't see around corners and such. But sometimes there's examples where we can see that. So small amount, for example, when you look at this picture here, you can see the eclipse here, right? So the diffraction pattern is made by light of a single wavelength shining around the edges of a very tiny disk. So this is not an eclipse, but it's similar to what would happen with that. So the edges kind of look blurry like that. So that's a great example of diffraction. So we mentioned interference the other day, just to review a little bit. So you have two or more waves that actually combine. Now, sometimes they overlap evenly on the troughs and the crests, other times they don't. So remember, if it's constructive, they're going to overlap evenly. If it's destructive, they're going to, and so if it's constructive, it would amplify the sound if it's a sound wave. And if it's destructive, it would be actually quieter. So if we look at it in terms of light waves, it looks a little different, right? So you have the red light of a wavelength passing between these two little openings, right? These little slits. And then they diffract as they move away from them, right? So here you have some overlapping happening because of those two openings. And this would be, you know, kind of the destructive piece of it. So if it we could see this on a screen. Constructive, it would be, you know, nice and amplified evenly. Destructive would be, you know, not. So that's kind of a good example. Looking at it a little bit differently than we did the other day. So I know I went through this kind of quickly. Feel free to rewatch the video or ask any questions when we meet up very, very soon. And we can go over things a little bit better or answer any questions that you might have.